GPUs are expensive and there are not many. That is why quantization makes a lot of sense these days. Quantization of LLMs is a technique used to reduce the size of the models and make it run faster while trying to keep its performance as close to the original as possible. Imagine you have a very detailed painting and you want to recreate it with fewer colors without losing the essence of the painting. In quantization, the vast numbers that the model uses to understand and generate text are simplified into smaller, more compact forms. This process is like shrinking the size of a heavy book into a pocket sized guide that you can easily carry around. By doing this, the model requires less computational power and storage, making it more accessible and efficient to use on a wide range of devices, from powerful servers to everyday smartphones. That is why this new technique of quantization, QuIP Sharp, is gaining a lot of popularity out there. This quantization technique uses post training quantization or PTQ. So, QuIP Sharp is a wait only PTQ method that achieves state of the art results in extreme compression regimes, or in other words, less than 4 bits per wait, using three new techniques. First, QuIP Sharp improves the incoherence processing from QuIP by using the randomized Hadamard transform, which is faster and has better theoretical properties. Secondly, QuIP Sharp uses vector quantization techniques to take advantage of the ball shaped sub-Gaussian distribution that incoherent weight possesses. Specifically, the researchers have introduced a set of hardware efficient codebooks based on the highly symmetric lattice, which achieves the optimal 8 dimension unit ball packing. Thirdly, QuIP Sharp uses fine tuning to improve fidelity to the original model. And a lot of experiments on QuIP Sharp has shown that it has already outperformed existing PTQ methods, and it has enabled it to depict new behaviors in PTQ scaling and supports faster inference. If you go through this GitHub repo, you will see that there are a lot of nuggets which are scattered throughout it, and they have already done some llama based model quantization, and you can find those models here on the Hugging Face. And I'll drop the link to this GitHub repo in video's description so that you can read further about it. And you can see there are a lot of models which they have already converted to 4-bit, 3-bit, and I believe there are also some 2-bit ones. There you go. So you can see that this is 2-bit one too. So llama 2 70 billion E8P 2-bit. So if I open this, go to files, and you'll be surprised to see the size of the file, 72 billion model, and just look at the size, how reduced the size becomes with 2-bit quantization. Amazing stuff. And then of course, if you look at even the smaller models with 2-bit quantization, the size really goes down and down. For example, if I show you the llama 2, let's check the llama 2 2-bit one. I'll just expand it. Hopefully it will be in the 2-bit section. There you go. So llama 2 7 billion chat. Let's see the size of the file. There you go, only 2.15 gig, which is nothing really. And still, as I said, of course there will be a performance hit, but not as much as you think. So pretty cool research, I must say. Now if you want to use it, all you need to do is to just git clone this repo and then install the requirements via requirements.txt, and this takes quite a long time. I have done it, and it takes 2 to 3 hours for me on my single GPU system. So that is one drawback I have found out with this. Anyway, once you have done it, just install QuIP tools and setup.install, and then off you go. You can start your quantization. They also have already shared some of the cookbooks and Python functions, such as this Hessian one, which you can use from it, and then you can do evaluation, text generation, and there is this also model zoo which I just showed you on the Hugging Face. Lot of things which you can go through it, and I would highly suggest that if you're interested in quantization, maybe give it a go, as it's quite fine. If you want to read more theory around this, there is an archive paper. You can access it by clicking here. That's it, guys. Let me know what do you think about this QuIP Sharp. If you like the content, then please consider subscribing to the channel, and if you're already subscribed, Please share it among your network as it helps a lot. Thanks for watching.